So we are interested in to determine whether students who first attended community college took longer to attain a bachelor's degree than those who immediately attended and remained at a four-year institution. So we already have an idea of the test of hypothesis, how it looks like, right? So mu1 equals mu2, and mu1, if our cohort for community college is the first one, then mu1 greater than mu2. Before, potentially, I don't even know what they're going to ask us, but right now they're asking us what is the response variable in the study and what is the explanatory variable. So remember, the explanatory variable is always the X variable, the one that creates the response. Okay? The data in the table attached below summarize the results, and the response variable is the use of community college or not. The explanatory variable is the time to graduate. So that makes sense. It's not the number of students, it's not the time students graduate, and it's not the response variable is, so the response variable is the time to graduate, right? The response variable is not if they went to the college, community college or not. That is the explanatory variable. The explanatory variable is, did they go to the community college or not? That's the explanatory variable. They say that if somebody starts, which I personally disagree, but we'll see what the data says, that students who had first attended community college took longer to attain a bachelor's degree. So the explanatory variable is, I did go to a community college or I did not. The response variable is, did it take me longer to complete the 4 years or not? So let's read those options and make a decision. So one more time, the explanatory variable is the X variable, is the input. Did I go to a community college or not? That's the explanatory variable. And the response variable, did it take me longer to complete 4 years or not? Or in other words, the time to graduate.
It is D.
Excellent, I completely agree. The response variable is the time to graduate. They are trying to base that on the fact that I may have gone to community college or not. That's what the study is all about. Good, excellent. Explain why this study can be analyzed using inference of two sample means. Determine what qualifications are met to perform the hypothesis test about the difference between two means. Select all that apply. Okay. So explain why the study can be analyzed using inference of two sample means. First of all, we know that the samples have to be independent. Are they independent? Yes. How do I know? Well, I select from students who went to a community college and students who did not. Those are not dependent because those who went to a community college are not the same with those who did not, or vice versa. So first of all, the samples have to be independent. Now, when we look at the sample size, 270 and 1,112, yes, the sample sizes are large. That's true. The sample sizes are not more than 5% of the population. That is true. They cannot be. It's not allowed, because the reason why it's not allowed to have more than 5% is because if we do select more than 5%, it is possible that at some point in time, dependence instead of independence comes into play. So that's why the restriction that the sample size cannot be more than 5% of the entire student population for both. The population is given to be normally distributed. No. The samples can be reasonably assumed to be random. Yes. So samples have to be random. So we are doing randomization. Samples have to be independent. Sample sizes are large. And the sample sizes are not more than 5% of the population. The only one that makes there is not a requirement is the population is given to be normally distributed. As long as the sample sizes are large, the samples are independent, they're not more than 5% of the population, and they are random, all the conditions of the test are fulfilled. Do you need me to write down any of this? I mean, we did many times, but if you need me to, or I can wait for you to write it down, or tell me what you want me to do. Okay, so does the evidence suggest that community college transfer students take longer to attain a bachelor's degree? And they're giving us alpha 0.01 level of significance, and perform a hypothesis test. Determine the null and the alternative. Okay, so let's determine the null and the alternative. Which one? Well, I haven't heard from Evan and Sasha, I think. Because with all my equipment in front of me, I can't see. Evan, are you with us? Sasha, are you with us?
Yes.
What do you think?
I think the answer is A.
Good. Thank you. Good. So let's determine the t-statistic. I copied the information so I can go directly to conduct a two-sample t-test, not interval, t-test. Stats, tests, two-sample t-test is number 4. Okay, so x1, 5.47. And then S1, 1.162. And then N is 270. And then 4.54. And 1.003. And 1112. And we want this. mu1 greater than mu2. And I want to draw. Where is the shaded area? Aha. Look at the p-value. How much? How much is the p-value?
0.
Yeah. Good. T-statistic, round to 2 decimals, 12.1. Huge. So far out from the mean. It says around to 3 decimal places, really. Nice. Should the hypothesis be rejected? Yes or no?
Do not reject.
The p-value is smaller than alpha.
Oh,
Rejected.
Right? P-value smaller than alpha, reject. There is sufficient evidence to reject. So reject. The evidence does not suggest a community college transfer. So we are rejecting, so careful because the claim is that it's greater. And the null hypothesis, that's all we are rejecting. We are rejecting the null hypothesis, which says that they are equal. So the evidence does suggest that community college transfer students take longer to attain a bachelor's degree at the level of 0.01, according to the data. So the evidence, so we reject the null hypothesis, they're not equal. So the evidence coming from the sample suggests that from this particular sample, transfer students take longer to attain a bachelor's degree at alpha 0.01 because we reject the null hypothesis, which means equal. Okay, now they want a 99%, which makes sense. 0.01 and 99. That's what I said all along. So now they want a 99%. Let's take a look to see, because we rejected, 0 cannot be there. If 0 is in the interval, then there is a conflict. Okay, so we have all this data already in there. And a 99, of course, careful. Calculate. And if 0 is there, then we have a problem. But 0 is not there. It's consistently positive. So 99% confidence interval, 0.73103, 1.129, consistently positive, which means mu1 is greater than mu2. Round to 3 decimal places. Okay, 0.731 and 1.129. Okay, do the results of part C and D reject? Yes. Imply that community college causes you to take extra time to earn a bachelor's degree? It appears that it's true from this data. Taking more time is not a bad idea in many situations. Do the results of part C and D imply that community college causes you? Not necessarily, it's not a bad thing. Causes you to take extra time to earn a bachelor's degree? The answer is yes, but that's okay. Yes. But this was not an observational study. Ah, because they used the word cause. Got it. Although this is not an observational study. So I see their point because it says the cause. They tricked me with the word cause. That's why I immediately said it's not a bad thing. So I should have been careful with the word cause. So from the study, it's correct, but it doesn't necessarily mean that that's the cause. That's what they're trying to say. That is correct. From the study that we have, we rejected they're not the same amount of time, are not equal. It appears to be more because the confidence interval is also consistently positive, but they caught me with the word cause because That's why I already said it's not a bad thing at all. So it doesn't mean that it causes. But that's, yep, that's an exercise in English language. I should have been more careful with the word cause. It doesn't cause, but from the sample, it's correct. They imply that community college, from the study, students who do not who transfer from the community college to the university or a 4-year institution may need more time to complete, but it doesn't cause them. That's the nuance here that I addressed it, but I didn't pay attention to select no, because it doesn't cause. Okay, good. Now, what was the other, V, you had a question. There was something about a quiz. Do you want me to look at the quiz? You want us?
I'm just asking, like, if we do the quiz,
Oh, you can do the quiz
really
many. Yeah, you can do the quiz many times. If there is a problem that you want us to look at right now, because we have a few more problems from the last section. So you want me to look at any of these problems in the quiz?
Yeah, just want to make sure is there any the same problem that we just did.
We can. Yeah, we're not, by browsing them, we are not going to be able to see all the questions. That's true. But send me an email and we can, if there is any difficulty, we can do this problem together on Monday.
Okay.
Not to worry. And remember the word cause, so you don't fall into the same trap I did. They tricked me, and I fell into the trap with the word cause. It doesn't cause. It's just the result of the test statistic. Okay. Give me 1 second so I can plug in my device. Okay, it's plugged in. Okay, so these are the last 6 questions that we need to look at, and there is no more new material after this. This is it. So let's complete these questions.